To write the equations, you're always going to be given a vertex, which represents h and k, and you're always going to be given a point, okay? And even though this doesn't say this is the point, okay, when you see the x-intercept, you know that that's a value that's x and 0. So the x-intercept is going to have a point that is 5, 0. If I had told you the y-intercept was a certain value, okay, that's also a point, and that means that x is always 0. So it's important to know that in these problems you're always going to be given a vertex and you're always going to be given a point. And the reason why is because if we're going to write an equation, we have to figure out what all these values are so that we can find a. So we can find the vertical stretch or compression. So 5 is x and 0 is y. So I look at this equation and I plug in all these values that I have. I know that y is 0. I'm looking for a, that's my first step. X is 5. H is 1, so I'm just going to subtract the 1. Make sure you square this value. And then I add k. But in this case, k is -3, so I'm actually going to subtract it. So now I just find a. And you're going to add the 3 over. And 5 minus 1 is 4. And 4 squared is 16a. Make sure you simplify. Now I'm going to divide by 16, and I get 3 over 16 equals a. So we found our a value, and then our next step in the problem is to say, okay, well, y equals whatever you found, 3 over 16 times x minus 1 squared minus 3. This is the equation, and all you do is substitute in the a value that you found and write it with the vertex in here. So now this equation will work for any quadratic with this vertex and this vertical compression.